All right, let's look at Chapter 5, Section 2, which is ratio tables. The essential question is, how can you find two ratios that describe the same relationship? Vocabulary. So we have equivalent ratios, and those are two ratios that describe the same relationship, and ratio table, and they're used to organize equivalent ratios. Okay, let's look at example 1, which is completing ratio tables. The directions say find the missing values in each ratio table, then write equivalent ratios. Okay, so in this first ratio table, so this is a ratio table, it's comparing the ratio of pens and pencils. So we know that for every one pen, there are 3 pencils. So the ratio is 1 to 3. And it's our job to find out what the pattern is and fill in these other 2 boxes. So let's look at our pens here. Let's look at our 1 and our 2. So what's happening between the 1 and the 2? Well, 1 plus 1 is 2, so we're adding 1 each time on top. So on the bottom, so for every 1 pen, there's 3 pencils. So we added another pen, so that'd be 3 more pencils. So we'd be adding 3 on the bottom. And we're adding 3 because we know for every 1 more pen, there's 3 pencils. So then this box, 3 plus 3 is 6. And then up top, well, our pattern up top is we're adding 1 more pen. And on the bottom, for each pen, there's 3 more pencils. So we're adding 3. And we're given the next number in our pencils row, which is 9. So that does fit our pattern because 6 plus 3 is 9. So that means up top, our pens, 2 plus 1 is 3. So that's completing our ratio table. That's the first step. Now we need to write our equivalent ratios. And to do that, we write the ratios that we found in our table. So the first ratio is 1 to 3, 1 pen for 3 pencils. The next ratio is 2 to 6, and I'm using the colon for the ratios. And the next one is 3 to 9. So those are equivalent ratios. These ratios, they equal the same thing. They're the same ratio. All right? Let's look at problem B. This time we're comparing dogs to cats. So we're saying for every 4 dogs, there are 6 cats. Okay, so let's find the pattern in this table. Well, we're given 6 and 12 right next to each other. So let's look at that. Well, I know that 6 times 2 is 12. So maybe that's our pattern. So times 2. So it would mean that this right there would be times 2 as well. Oh, and I forgot, in this problem we were also given this box is 16. Okay, so let's see if that pattern works for on top too. Let's see if the top is also times 2. So 4 times 2, well, that's 8. And then if we're keeping with the same pattern, that would mean that between these 2 boxes, the difference is times 2. Let's see, 8 times 2, oh, that is 16, so that pattern works. So on the bottom, we're going to take 12 times 2, and I know 12 times 2 is 24. Okay, so for this one, we stuck with the same pattern. We multiplied every number by 2. And these are and then we need to write the equivalent ratios. And for that one, we're just copying the numbers that we found in the table. So our first ratio was 4 to 6, and then 8 to 12, and then 16 to 24. Okay, one more. I encourage you to pause the video and see if you can find the pattern for this bottom one. Okay, this time we're comparing apples to bananas. And I'm just going to fill in these little carets here because that tells us, so we're going to fill in what our pattern is. Okay, so let's look at the bottom because we have two numbers next to each other. Well, I know that 3 plus 3 is 9, so maybe that's our pattern. Let's see, 3 plus 3 is 9, so that would mean we're going to take 4 plus 3, and that would be 7. And let's do 7 plus 3. 7 plus 3 is not 36. So it's not plus 3. That's not our pattern. Well, 3 times 3 is also 9, so maybe it's times 3. Okay, so let's see if that works on the top. 3 times 3, or 4 times 3, excuse me, would be 12. And then, let's see, 12 times 3. Oh, that is 36. So I think times 3 is our pattern. So you kind of have to try it out a little bit and do some trial and error. See if the numbers all fit. Okay, times 3. So I mean 36 times 3, that is 108. Okay, let's look at the bottom. So we're saying times 3 is our pattern. So we're going to take 9 times 3, and that's 27. And then we're going to take 27 times 3. And 27 times 3 is 81. Okay, now we just need to type out our equivalent ratios. And the first one was 4 to 3 so for 4 apples, there are 3 bananas. And then, so that means that if there's 12 apples, there's also 9 bananas. If there's 36 apples, there would have to be 27 bananas. And if there were 108 apples, there would have to be 81 bananas. Those are all equivalent ratios.